Welcome to the material session of Pulsar's Career Point. This is a video for the student of class 12 on Unit 8. The first chapter of this unit is Aldehyde and Ketone. This is the 15th video of this chapter covering the topics the chemical properties of aldehyde and ketone for reduction. Aldehyde and ketone can undergo catalytic reduction, reduction with HI in red phosphorus, Clemensen's reduction, and Wolff-Kishner's reduction. Let us come for catalytic reduction. How aldehyde and ketone undergoes catalytic reduction? Aldehyde or ketone undergoes reduction in the presence of catalyst like Rani nickel, platinum or palladium, lithium aluminum in ether, or sodium borohydride, or sodium in alcohol. Then what happens? The pi bond between carbon and oxygen of carbonyl group undergoes reduction. The pi bond breaks down and two H's are added to carbonyl carbon and carbonyl oxygen respectively to give corresponding alcohol. So what we have to write down? When aldehyde or ketone undergoes reduction in the presence of catalyst like Rani nickel, platinum or palladium, or lithium aluminum hydride in ether, or sodium borohydride, or sodium in alcohol, then corresponding alcohol is formed. Now, for aldehyde, if aldehyde undergoes reduction in the presence of Rani nickel, platinum or palladium, or lithium aluminum hydride in ether, or sodium borohydride, or sodium in alcohol, then corresponding primary alcohol is formed. Here the alcohol form is called primary alcohol because the carbon atom to which the OH group is attached in turn attached to one alkyl group and two hydrogen atoms. As only one alkyl group is attached to the carbon atom to which OH group is attached, so it is a primary alcohol. So in the statement we have to write down when aldehyde undergoes reduction in the presence of catalyst like Rani nickel, platinum or palladium, or lithium aluminum hydride in ether, or sodium borohydride, or sodium in alcohol, then corresponding primary alcohol is formed. Let us come for example. Let us take CH3 in place of R. Then the aldehyde will be acetaldehyde or ethanol. After reduction with nickel, platinum or palladium, or lithium hydride in ether, or sodium borohydride, or sodium in alcohol, then it will give us ethyl alcohol or ethanol. So in the statement we have to write down when acetaldehyde undergoes reduction in the presence of catalyst like Rani nickel, platinum or palladium, or lithium aluminum hydride in ether, or sodium borohydride, or sodium in alcohol, then ethyl alcohol or ethanol is formed. Now let us come for ketone. How ketone undergoes catalytic reduction? Whenever ketone undergoes catalytic reduction, it will give us corresponding secondary alcohol. Because the alcohol to which the compound in this alcohol, the carbon atom to which OH group is attached, in turn attached to two alkyl groups. Thus in statement, you have to write down, when ketones undergoes reduction in the presence of catalyst like Rani nickel, platinum, or palladium, or lithium aluminum hydride in ether, or sodium borohydride, or sodium in alcohol, then corresponding secondary alcohol is formed. For example, let us take C3 in place of R. Then the given ketone will be acetone or propane 2ONE or simply propanone, which undergoes reduction in the presence of catalyst like Rani nickel, platinum or palladium, or sodium borohydride, or sodium in alcohol, or lithium hydride in ether. Then it will give us isopropyl alcohol or propane 2ONE. In the statement we have to write down when acetone undergoes reduction in the presence of catalyst like Rani nickel, platinum or palladium, or lithium aluminum hydride in ether, or sodium borohydride, or sodium in alcohol, then isopropyl or propene 2ONE is formed. Now let us come for reduction with HI in the presence of red phosphorus. How does aldehyde or ketone undergo reduction with HI in the presence of red phosphorus at about 423 Kelvin temperature? Then it will give us corresponding alkane. 4 hydrogen atoms are added to carbonyl group, 2 hydrogen atoms to carbonyl carbon, and 2 hydrogen atom to carbonyl oxygen, as a result of which one water molecule it by mistakenly 2 water molecule it should be corrected to 1 water molecule. When aldehyde or ketone under reduction with HI in the presence of red phosphorus at about 423 Kelvin temperature, then corresponding alkane is formed. ତାହେଲେ ପିଲାମାନେ ମନେ କରି ଏଠି ୱାଟରଟିକୁ ଗୋଟିଏ ବୋଲି ନେବ 1 water and 2 H2 ଦେବ. So in the statement we have to write down when aldehyde or ketone undergoes reduction in the presence of HI undergoes reduction with HI in the presence of red phosphorus at about 423 Kelvin temperature, then corresponding alkane is formed. For example 1 is whenever formaldehyde undergoes reduction with HI in the presence of red phosphorus, then methane is formed. In the statement we have to write down when formaldehyde undergoes reduction with HI in the presence of red phosphorus at about 423 Kelvin temperature, then methane is formed. Let us come for example 2. Let us take acetaldehyde C3H. When acetaldehyde undergoes reduction in the presence of undergoes reduction with HI in the presence of red phosphorus at about 423 Kelvin temperature, then ethane is formed. Thus, in the statement we have to write down when acetaldehyde undergoes reduction with HI in the presence of red phosphorus at about 423 Kelvin temperature, then ethane is formed. Example 3. How does acetone undergo reduction with HI in the presence of red phosphorus? Whenever acetone undergoes reduction with HI in the presence of red phosphorus at about 423 Kelvin temperature, then 4 hydrogen atoms are attached to carbonyl group. Will get propene, water, and 4 iodine gives us 2I2 molecule. Thus, in the statement we have to write down when acetone undergoes reduction in the presence of red phosphorus, undergoes reduction with HI in the presence of red phosphorus at about 423 Kelvin temperature, then propane is formed. Now, let us come for the Clemensen's reduction. A very important point. Clemensen's reduction. What do you mean by Clemensen's reduction? Now, aldehyde or ketone undergoes reduction with zinc amalgam and constant ACl. Then corresponding alkane is formed. In the statement we have to write down when aldehyde or ketone undergoes reduction in the presence of zinc amalgam and constant ACl, then corresponding alkane is formed. This reduction is called Clemensen's reduction. For example, let us take example 1. Let us take formaldehyde. When formaldehyde undergoes Clemensen's reduction, then it will give us methane. The carbon and oxygen will be removed as water molecule. 2 hydrogen atoms are attached to carbonyl carbon to give us methane. In the statement we have to write down when formaldehyde undergoes reduction in the presence of zinc amalgam and constant ACl, then methane is formed. Let us come for example 2. What happens when acetaldehyde undergoes Clemensen's reduction? Whenever acetaldehyde undergoes Clemensen reduction, it will give us ethane. In the statement we have to write down when acetaldehyde undergoes reduction in the presence of zinc and mercury amalgam in constant ACl, then ethane is formed. Let us come for example 3. How does acetone undergoes Clemensen's reduction? Whenever acetone or propene 2ONE undergoes reduction in the presence of zinc amalgam and constant ACl, then propane is formed. In the statement we have to write down when acetone undergoes reduction in the presence of zinc amalgam and constant ACl, then propane is formed. Now, let us come for another reduction, that is Wolff-Kishner's reduction. In the Wolff-Kishner reduction, aldehyde ketone में से alkane पाइबो, but indirectly, first of all, aldehyde and ketones are treated with hydrazine to give us corresponding hydrogen, which in treatment with KOH in glycol gives us alkane. So in the statement we have to write down when aldehyde or ketone undergoes reduction with hydrazine and KOH in glycol, then corresponding alkane is formed. This reduction is called Wolff-Kishner's reduction. Let us come for example. In the example 1, let us take formaldehyde. What happens when formaldehyde undergoes Wolff-Kishner's reduction? Whenever formaldehyde reacts with hydrazine, then water molecule is eliminated and formaldehyde hydrazone is formed, which in treatment with the KOH in glycol gives us methane. So in the statement we have to write down when formaldehyde undergoes reduction with hydrazine and KOH glycol, then methane is formed. Let us compare example 2. What happens when acetaldehyde undergoes Wolff-Kishner reduction? When acetaldehyde reacts with hydrazine, it will give us acetaldehyde hydrazone, which in treatment with KOH glycol gives us ethane. In the statement, we have to write down when acetaldehyde undergoes reduction with hydrazine and KOH in boiling glycol, then ethane is formed. Let us compare example 3. What happens when acetone undergoes Wolff-Kishner reduction? When acetone reacts with hydrazine, then acetone hydrazone is formed, which on treatment with KOH in glycol gives us propane. So हमको propane दो. Now, in the description, what you have to write down? When acetone undergoes reduction with hydrazine and KOH in boiling glycol, then propane is formed. Thanks for watching Bhopal Search Career Point. Please like and share this video. Don't forget to subscribe my channel if you are watching it for the first time. Don't forget to hit the bell icon to get timely updation of my new video.